All right, so we've done some simultaneous linear equations. Yeah, I've improved on that. We've done some linear equations, and what we're going to do now is something a bit more, not complicated, but a bit more extra, a bit more useful in the real world. So what we're talking about is feasible regions, okay? Now what I mean by that is something you're going to see as we go ahead. All right, and I'm going to explain it with an example. All right, so you go to a tutoring service, okay? Maybe it's prep folders. All right, and you've got a bunch of options and you want to do the best you can on your ATAR, right? So your options are either they offer a 2-hour tutoring for physics, or they offer a 1-hour tutoring for maths, okay? And now you only have 10 hours of tutoring available. You cannot get more than that, okay? That's your limit. So the question is, if you could study for all those 10 hours, in how many ways can you get these tutorings, okay? How can you distribute your tutoring times so that you end up with 10 hours, okay? Now, the way to think about these things is you can just start off by saying, okay, what I can do is I can get one physics tutoring, okay? And I can get 8 maths tutorings, okay? That would give me 10 hours, all right? Or what I can do is I can get 3 physics tutorings, okay? And that will give me enough time for 4 more maths tutorings, okay? And you can do this sort of meddling around, fiddle it, change the numbers a little bit, and get a bunch of different answers, okay? What I'm going to do is show you something a little bit more interesting, all right? I can give you a table, all right? And it's in this table I can show you the physics lessons you have and the number of math lessons you have, okay? Okay, so you can either get 1 physics lesson and get 8 math lessons, like we said. You can get 2 physics lessons, which would be 4 hours, leaving you with 6 hours for your math lessons. You can do 3 physics lessons, okay, which would leave you with 4. 4 would leave you with 2, and I'm sure you can see the pattern. 5 is leave you with 0, okay. And we've got one more value that I forgot. We can do 0 physics lessons and 10 math lessons, okay. So these are essentially all the values. Now, when I first talked about these tables, I'm pretty sure we went into linear functions. So why not do the same thing here? Okay, so I have a linear function, okay? These points, I can plot them as a function. So my function could be like this, all right? It starts at 10. I need to define my x and y axes first, right? So in this case, my x-axis is the let's see, what do we want? We want it to be the physics, right? Okay. So this is my physics lessons, and these are my math lessons. Okay. So if I get 10 math lessons, I get 0 physics lessons. That makes sense. Okay. If I get one physics, I get 8 math lessons. 6, 4. Whoops. Whoa. What happened there? There we go. And then 2. Obviously, it's not drawn to scale, so don't grill me for it, but yeah, I think you get the point. Okay, so this would be sort of our, not a very straight line. Okay, so this would be sort of the equation, sort of the linear equation represented for this sort of scenario. Okay, now as you can see, all the points that are on this line are valid ways to distribute our time so that we spend all our 10 hours and we get a bunch of tutoring in. Okay, so these are what we call feasible solutions. Okay, all these points here are feasible solutions. Okay, and they represent all the solutions such that the time spent is equal to 10. All right. Now, what you need to realize is that any point that is above this line, right? Any point above this line, for example, this point here, it's going to result in a total hours of more than 10. You can check it, right? You can check any point here. At this point, let's say is what, 10 comma, what is this? Like this is almost around 4, 3, let's say. That's 13, more than 10, okay? This point here, all right? Let's say it's 4 comma, how many physics lessons is this? This is, let's say, 6 physics lessons, all right? 6 times 2, 12, plus 4, 16, more than 10. You can do it literally right on top of the line, right? This point here, let's say it's 5 comma, what is this, 3, right? 3 times 2, 6, 6 plus 5, 11. So it will always be more than 10. So essentially my point is that every value above this line is not feasible, okay? This area is not feasible for us. Similarly, every value underneath the line is going to be less than 10 hours. So these are also, depending on your constraints, these can also be feasible. But it depends on what you want. If your idea is that I want a minimum of 10 hours, then obviously you can go above the line. If your idea is I want a maximum of 10 hours, then you can go below the line. And that's sort of the idea what we're looking for. And in these feasible sort of constraint sort of problems, this is what we want to end up with. We want to end up with a graph where we can show which areas are feasible for us. Okay, and obviously in a similar context, if you only want solutions that are exactly 10 hours, it would be only on the line. So I hope you're getting the sort of the gist here. All right, and yeah, that's basically what you do when you have a feasible solutions problem. Okay, now I could make it a little bit more restrained. All right, and this is where you will really start to see the power of graphing like this, right? Now let's say I add in the constraint that I need to have at least 2 physics lessons, okay? And I need to have at least, let's say 4 math lessons, okay? And that's, we know that works because 2 times 2, 4 plus 4, 8. Okay, that's all good. Right, so how do I represent that here? Okay, I can make it very clear here by going, physics needs to be greater than or equal to 2. So 2 is about here. Okay, so we need to be on the right of this line. Okay, because we need to have more than 2 on the x scale. At the same time, maths needs to be greater than or equal to 4. Okay, so we need to be above this line. Okay, so now what was originally our feasible region was this, right? Originally our feasible region was all of this. Now it has been shrunk to just this, and it was so easy to determine what that was by graphing it. Okay, and we can add as many constraints as we want. So we can have an upper limit on physics, you know, it needs to be between this and this, whatever you need it to be, and it makes it so much more easier to do it because we have a graph in front of us. Okay, and that's really how powerful this method is for looking at feasible regions. Okay, so feasible regions, I forgot to define it, but it's really the places where you can satisfy constraints related to inequalities. All right, it's like simultaneous equations, but instead of having one solution, you have an area of solutions. Like you can see here, this whole area is all feasible. Now there is an important question: are the lines included or not? Okay, now that depends on the inequality itself. If the inequality is less than or equal to or greater than and equal to, then the lines are considered. All right, and you would draw the lines as fully proper normal lines. But if it is greater than equal to, right, like it doesn't have, sorry, greater than 4, it doesn't have the equal to there, what you would want to do is, rather than drawing a proper line, proper solid line, you're going to have to draw a dashed, you're going to have to draw a dashed line. Okay, and then the line is not included in the solution. That is all there is to feasible regions, and once you start doing problems, it will start to make a little bit more sense, all right, how to go about things. But yeah, that's really all there is to it, and hopefully all of that made sense. If not, please do not hesitate to contact and ask some questions. But good luck. Hey guys, two things. If you do have any questions regarding the content we just covered, just go ahead and drop that in the comments. I'll make sure to get to that as soon as possible. And secondly, if you like the video, or if you got anything that was useful from it, make sure to check out the website, Prep Folders. There's so many more videos like this, so many more resources, practice questions and all the lot. So just go ahead and have a look. If you need help, there's some tutors and mentors there as well. So just have some fun over there. And yeah, we'll see you on the other side.